Imagine a world where you could have a conversation with your electronics, and they could respond. Welcome to the realm of UART, a simple yet powerful communication protocol that brings this concept to life by allowing devices to talk to each other. So, what is UART? UART, or Universal Asynchronous Receiver Transmitter, is like a universal translator for electronic devices. It's a hardware protocol that lets different devices exchange information. And how does UART work? In UART communication, data is sent and received one bit at a time. Unlike synchronized communication, there's no shared clock between devices. Instead, start and stop bits define the data bytes beginning and end. Imagine UART communication like a simple conversation. When one device speaks, it starts by saying hello, then shares the message, and finally signals goodbye. The other device listens, understands, and replies in the same manner. The speed of this conversation is defined by the baud rate, measured in bits per second. Common rates include 9600, 19200, 38400, and 57600 bits per second. UART is the communication superhero of the electronics world, used in a multitude of devices. It's the silent conductor, facilitating seamless exchanges, like sharing temperature data from a sensor to a microcontroller or directing a motor controller. Why is UART so amazing? It's simple, versatile, and budget-friendly. It's the perfect starting point for anyone stepping into the electronics universe. In this video, we'll delve deeper into the fascinating world of UART, unlocking its potential for beginners in electronics. Before we delve deeper into UART, let's grasp the fundamental concept of communication protocols. In the digital world, devices need a common language to communicate effectively. This is where communication protocols come into play. Think of communication protocols as sets of rules that define how data is transmitted, received, and interpreted between devices. Much like humans speaking different languages, devices use various protocols depending on their functionalities and compatibility. In our tech-savvy world, some popular communication protocols include UART, SPI, I2C, and CAN. Each protocol has its own strengths and weaknesses, making them suitable for specific applications. In this journey through UART, we'll focus on unraveling the magic of this versatile and widely used protocol. Now that we've set the stage, let's dive into the fascinating world of UART. Welcome to the core of UART communication, where we'll break down the basics of this powerful protocol. In the world of electronics, UART, or Universal Asynchronous Receiver Transmitter, is the unsung hero that enables data exchange. To truly understand UART, let's unravel its components. UART communication is a serial data exchange. Instead of sending data all at once, it's sent bit by bit. And here's the twist, UART is asynchronous, meaning there's no shared clock between devices. To kickstart UART communication, one device sends a start bit, followed by the data bits and a stop bit to mark the end of each byte. Picture this, when one device wants to communicate, it's like saying hello to another device, sharing its message bit by bit, and then saying goodbye. The receiving device listens for the hello to start reading, and when it hears goodbye, it knows the message is complete. This conversation happens at a specific speed known as the baud rate, measured in bits per second. Understanding the baud rate is key to successful UART communication. So, to recap, UART involves transmitting data serially, asynchronously, and at a defined baud rate. Now that we've laid the foundation, let's delve even deeper into the wonders of UART. Now that we've grasped the basics of UART, let's uncover the magic of how it works in detail. UART communication is typically carried out using two wires, a transmit TX line and a receive RX line. When one device wants to send data, it initiates the conversation by sending a start bit, think of it as saying hello. Following the start bit, the data bytes are sent one bit at a time. Each data byte is followed by a stop bit, our goodbye. Now, let's see this in action. As one device transmits data, the other device listens and deciphers the hello to start reading the message. The receiving device keeps an eye on the goodbye to know when the message is complete. Remember the baud rate we talked about? Both devices must be in sync, communicating at the same speed. This synchronization ensures a seamless conversation between the devices. By now, you're getting the hang of UART, where devices talk to each other in a synchronized yet asynchronous manner. But wait, we're just scratching the surface. There's so much more to explore in the world of UART. In this section, we venture into the real world to see how UART is making a tangible impact. UART isn't just theory, it's a key player in everyday electronics. One of UART's most common applications is in the realm of microcontrollers. It's like a secret language among devices, allowing them to understand each other effortlessly. Think about sensors. UART enables them to share data with precision. For instance, a temperature sensor can effortlessly relay its readings to a microcontroller using UART. The microcontroller, in turn, can process this data and take actions accordingly. And this is just the tip of the iceberg when it comes to UART applications. We're only getting started. UART's influence in electronics is vast and fascinating. UART, the unsung hero of data communication, offers a treasure trove of benefits. Let's explore its advantages. One of UART's standout features is its simplicity. It's user-friendly, making it a top choice for beginners in electronics. UART is known for its versatility. It plays well with a wide range of devices, making it a go-to for many electronic applications. But that's not all. UART is budget-friendly, too. Whether you're a hobbyist or a professional, UART keeps your budget in check. So, to sum it up, UART is simple, versatile, and cost-effective. It's no wonder that UART is cherished by electronics enthusiasts around the world. And this is just the beginning. UART holds even more secrets waiting to be discovered. Ready to embark on your own UART journey? Let's get you started with setting up UART. First things first, you'll need the right hardware. This includes a microcontroller or any device with UART capabilities. Next, you'll need to connect the TX and RX pins of the devices you want to communicate. It's like linking two walkie-talkies for a conversation. Now, you'll need to set the baud rate. This ensures that both devices communicate at the same speed. And that's it. You're all set up for UART communication. You've taken the first step into the exciting world of UART. Now, it's time for some real-world action. It's time for hands-on action. In this section, we'll connect an ESP32 Rover kit to a PC using an FTDI to TTL serial converter and terminal software. First, let's meet our star, the ESP32 Rover kit. This powerful device supports UART communication and is ready to share its data. To make the connection, we'll use an FTDI to TTL serial converter. This nifty gadget acts as a bridge between the ESP32 and your PC. Now, let's establish the physical connection. Our connection is complete, but there's one more crucial element: terminal software. This software is our window to the UART conversation. Let's open the terminal software and configure it to listen to the UART data. And now, it's showtime. Watch as the ESP32 shares data with our PC in real time. Congratulations! You've just witnessed UART communication in action. Now you're ready to explore the limitless possibilities of UART in your own projects. For those embarking on their UART journey, we've got some valuable tips to ensure a smooth start. Tip 1. Start simple. Don't overwhelm yourself. Begin with basic connections and gradually move to more complex projects. Tip 2. Learn baud rates. Understanding baud rates is key to successful UART communication. Take the time to grasp this concept. Tip 3. Read documentation. Device documentation is your best friend. Read it thoroughly to understand UART capabilities and requirements. Tip 4. Experiment and learn. The best way to master UART is by doing. Experiment with different setups and learn from your experiences. And that's a wrap. These tips will guide you as you explore the world of UART. The end of our UART journey. Let's wrap it up. In this video, we've uncovered the magic of UART, from its basics to real-world applications. UART's simplicity, versatility, and cost-effectiveness make it a standout choice in electronics. Now, it's your turn to explore the endless possibilities of UART in your projects. For beginners, remember our tips: start simple, learn baud rates, read documentation, and don't hesitate to experiment. Thank you for joining us on this UART adventure. Stay curious, keep experimenting, and unlock the potential of UART. In this video, we've scratched the surface. The world of electronics and UART has so much more to offer. Stay connected, keep learning, and don't forget to like, subscribe, and share this video to support our channel. Until next time, happy exploring and happy tinkering.